is when a gland releases a hormone, particularly, that has to go through the whole blood. So the endocrine system is using long-distance communication. In which case, here's the endocrine gland releasing a hormone, that's what these green balls are, floats through the blood until it binds to the target tissue. And it causes the target tissue to do something. That's how the endocrine system is going to manage. And then cytokines are kind of like hormones, but different in that they have a broader target range, produced by all cells with a nucleus, produced only on demand. These are the things that they do. So cytokines and hormones would be similar. All right, now let's talk about the receptor. Okay, a cell cannot hear the message unless it has a protein receptor to hear the message, like a doorbell. You don't know somebody's at the door unless there's a doorbell. And then they deform, they change the shape of the doorbell, and now you know that somebody wants to give you a message. And whether or not it can cross the cell membrane determines where that cell receptor is going to be found, inside or outside. So the cell receptor could be embedded on the outside of the plasma membrane, or it could be inside the cell, either in the cytoplasm or in the nucleus. So we have to take a little trip to Kinko's. All right, y'all don't know what Kinko's is, for the most part. Does anyone know what Kinko's was? I should say. No? Yeah. It used to be a freestanding copy store. And they would do copying and laminating and binding and all kinds of stuff for you. And then it became Kinko's FedEx. So then they started doing some FedExing. And then it became FedEx Kinko's. And then it just became FedEx. And so now there are freestanding FedEx stores in big cities particularly that also do all the copy stuff too. But I'm old, so I'm gonna go with the Kinko's name. All right, I have a message, and I just grabbed a piece of paper that was not somebody's graded stuff. That's the important part. Not passing around somebody's homework. And I need copies of this. And I am polar. So I go up to the cell membrane. Can I cross it? No. Nope, I can't, because I'm polar and the membrane's non-polar. So I have to find a protein receptor. Look at that, she changed shape. I give her the signal, she changed shape. I let go and I float away, or I'm degraded by enzymes or something. Something happens to me, okay? I deliver the message and I leave. Now what happens? Notice she changed shape. So she now turns around and begins activating proteins on the inside of the cell. So turn around. Look at how she changes shape as you hand that to Kendra. Kendra changes shape. We just activated an enzyme. And then she hands it over to Candace. Sorry, I have a Cassidy in my other class. And so when I start the CA, I have to stop and think. Candace. Notice that she changed shape. Then she carries on. Changing shape, carrying on, changing shape, and then all the way to the back, changes shape. All right, what happened here was copies were being made, paper was being loaded, toner was being added, staples were added, paper was added, then somebody hit the start button, then somebody started packaging it up as copies, 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 and then these guys punched holes in it, and that guy put it in a box, ready to ship it outside the cell. It happens normally quicker. Y'all were a little slow. When I did this for the science Phys class last week, they had moved all the way back to the cell before I even finished my sentence, which was an excellent point. The second messenger system acts very quickly. It acts immediately, within minutes at most, seconds usually. It happens quickly, and then it's over quickly. And if we need more response, well, we have to have another messenger come and deliver another message if we needed more copies of something. Okay, got that? Okay, now let's say that I'm non-polar. I just go in and make my own damn copies. Actually, what I do is I find the receptor deep within the cell, and I begin the process of making proteins. Make some proteins for me, baby. So I start genetic transcription. that takes time. 60 minutes, hour, hour and a half, days. So anything that's a non-polar messenger acts slowly, and that's what the steroids are doing. So steroids are all activating proteins being produced, and that takes time, which means it takes a while to get a product, but it also means that it lasts longer. So a little dab will do ya in that case. Okay, questions about that? And usually once I do that, students get that whole polar, non-polar, outside, inside thing.